I'm Anil Kumar. Welcome to my series on inequalities. We had talked about when and where to use and or in inequality. Here, with the help of four examples, we'll further discuss the same topic. This time, the question is write an inequality for the given solution. So, we are given the solution and we'll write the inequality. A. X is less than minus 2 or x is greater than 2. B. X is greater than minus 3 and x is less than 3. So what you notice here is that we have solutions with or on this side and on this side. C and D, I have changed the points so that the question really becomes slightly more difficult. Now let's look into writing inequality from the solution. Now what is the solution? I'm trying to solve the very first one. Let me rewrite the question here. A, which is x is less than minus 2 or x is greater than 2. What does it mean? It means that if I have a number line and on a number line, we are saying the solution is that if this is 0, we are looking for a solution where x is on the left side of minus 2, not including minus 2, or it is on the right side of 2, something like this. So we have minus 2 left side and right side. We have to write an equation, rather an inequality, whose solution will be this. So as you can see, a very simple solution could be a parabola, which could be like this, and whose solution will be on this side, right? That means I could write an equation which is, let us say, x squared minus 4, and since it is or, it has to be greater than 0. Do you see that? So it is greater than 0. The parabola, as shown here, and you can see it matches the solution. Perfect. If I have to write as an absolute function, I could also write absolute function as absolute x is greater than 2. So both are examples of inequalities whose solution will be as given. Perfect. Let's take part B now and see how to do when we are considering and. So in B, what we have is that x is greater than minus 3 and, let me write in capitals, x is less than 3. It means what? It means that if this is minus 3 and this is 3, then we are looking for overlapping. So when we say x is greater than minus 3, it means this side, right? And when we say x is less than 3, it means this side. What is common? And means intersection. What is common between the two? Everything in between. So that is what and is. Perfect. So and is used when we have an interval which is kind of continuous as shown here, and or is used when we have a split interval. So that is what I want to specify. Now, if I have to write an equation, then again I can take an example of a parabola, kind of like this, right? And write down an equation that x squared, now plus minus 3 square root is of 9, right? And we are interested in the portion which is this portion. Parabola less than. Perfect. And therefore, it has to be less than 0. Do you get the idea? If I have to write an absolute function, I could write absolute x is less than 3. Since absolute x could be plus or minus, right? So I hope the concept is clear. Now with this concept, let's move on to C and D, which are kind of challenge questions. So I'd like you to now pause the video, find the solution for C and D, and then check with my solution. Now let's take up example C and D. We have to write an inequality for the given solution. The solution is, the first one here, C, is x is less than minus 5. Let's go this side of minus 5, and is greater than 3. We need to write some inequality. Now writing a quadratic equation could be simple. We could use these as the factors, right? So we could say x plus 5 times x minus 3. And since it is OR operation, right, we say greater than 0. Now the question is, how to write absolute function? That is a challenge sometimes. So I'll teach you that part in this. So what we do here is to find a midpoint. So midpoint here is minus 5 plus 3 divided by 2, which is minus 1. So at minus 1 we have midpoint. From midpoint, how far are we? So this distance is how much? That is what we need to see. Well, this distance is the same as the other distance, and it is 3 minus minus 1, which is 4 units. Since it is 4 units, we could write our absolute function as absolute x minus means moved 1 unit left, so we'll write plus 1. And since it is going away, we'll say greater than, and the value is 4. So that becomes the equation, rather inequality, whose solution is given to us. So I hope these steps are clear to you, right? It's kind of tricky, but very useful. Now let me take D. In D, we are given AND condition. X is greater than minus 3. That means it is on this side of minus 3. X is less than 7. So let's say this is 7 for us. Less than 7 means this side. AND means what is common to both. That means in between. So as far as this quadratic function is concerned, we could easily write this as x plus 3, that is the first root, x minus 7, the other root, and means less than 0. So that is the inequality which satisfies. How will you write as an absolute inequality? Well, the concept is simple. We have to find the midpoint. So the midpoint again here is minus 3 plus 7 divided by 2, which is 2. So that is 2. And how far are we? We are 5 units away, right? So the inequality becomes, move the absolute function to 2 units right, and we are looking for something which is right in between, and it is 5 units away. So that is how we get our absolute inequality for the given solution. So what we learned here is that if we are given a solution of an inequality, we could always write the equation. In this particular video, I have shown you how you could write equation as a quadratic function or as absolute function. Second, we again touched upon the topic of AND and OR. We are using OR most of the time when there is a split in the solution, and AND when it is just together. So I hope this is clear. Thanks for watching and all the best.